Hi everyone, welcome to Algo Coding. In this video, we are going to solve the classic coin change problem using a recursive approach, which will allow us to explore the concept of recursion in depth. Let's review the problem statement together. Suppose that you are given an unlimited supply of coins of different denominations, and you need to find the number of ways to make change for a value of n. For example, consider amount 5. We are going to count all the combinations to make amount of 5 using coin values of 2, 3, and 5. How can we do it? I can add up a coin value of 2 and a coin value of 3, or just pick a coin value of 5. So totally there are 2 ways to make the amount 5. In the first way, we have included a coin of 2 and a coin of 3 and excluded a coin of 5. In the second way, we have excluded a coin of 2 and a coin of 3 and included a coin of 5. So there are two options for each coin. We may exclude it or include it. As we are studying this problem using recursive approach, let's draw a recursion tree to see how this problem is resolved using recursion. Okay, now starting point is where the amount is 5, coins are 2, 3, and 5. As I said, for each coin, there are 2 options. Starting with coin 2, there are 2 options for coin 2. We may exclude it or include it. If we include coin 2, the amount will be 5 minus 2, 3. Coins are the same. But if we exclude coin 2, the amount will be the same, but the coins are 3 and 5. Okay, what just happened? We just divided the problem into smaller subproblems. And now we have smaller problems similar to the main problem. This approach or this technique is called divide and conquer. We need to solve subproblems recursively so that we'll arrive at the solution of the problem by combining the solutions of the subproblems. So let's find the solution of each subproblem. Continuing on this branch, again, if we include coin 2, the amount will be 3 minus 2, 1. Coins are 2, 3, 5. If we exclude coin 2, the amount will be 3, but the coins are 3 and 5. As you can see, we just repeated this step. In the previous step, we have include coin 2 or exclude coin 2. In this step, we also have include coin 2, exclude coin 2. So we are recursively breaking down the problems into smaller subproblems. Again, we'll continue on this branch. Include coin 2, exclude coin 2. Okay. Now, if we include coin 2, the amount will be negative 1. So now the amount is negative. This is where the recursion stops or bottoms out because we can't go down further. This is how you recognize a base case. Once the subproblems become small enough that we no longer recurse, we say that the recursion bottoms out and that we have gotten down to the base case. What does it mean? It means that there's no solution on this path. And obviously, if we include 3 coin 2, we won't get to the amount of 5. So I turn the color of this box into red to identify it as a base case which doesn't reach to a solution. I also write here that our base case happens when amount is negative. Okay, let's continue. If we exclude coin 2, the amount will be 1. Coins are 3 and 5. Again. Now the coin is 3. If we include coin 3, again the amount will be negative, and it will be negative 2. So I turn it into red, which is obvious. If I include a coin of 2, 2 coin of 2 actually makes a 4, and then I include a coin of 3, it makes 7 on total. So it won't make a 5. If I exclude coin 3, will be 1 and 5. Okay, now the coin is 5. If I include coin 5, the amount will be negative 4, which is a negative amount. So this is a base case, and there's no solution on this base case. So I turn it into red. And if I exclude coin 5, the amount will be the same, but we ran out of coin and there are no more coins left. So this is another base case. I add it here. The other base case is no more coins left. This is another base case. So there are 2 base cases in this problem. Back to the top, we continue on this branch. Here we have amount 3 and coins are 3 and 5. So if we include coin 3, the amount will be 0. So we reached another base case. Here we can't continue anymore because the amount is 0. And this is a happy state because it means that a solution is found. Obviously, if you include a coin of 2 and then you include a coin of 3, you'll get a 5. So this is a solution. I turn the color of this box into green. So another base case is when the amount equals to 0. It means that we have found a solution. And then recursion stops there. If we exclude coin 3, the amount is the same. And coin is 5. We continue. If we include coin 5, the amount will be -2, which is a base case, and it says there's no solution here. We won't go down further. And if we exclude coin 5, the amount will be 3, but no more coins left. So This is another base case which stops the recursion. Back to the top, there's still one node left. Continue. Here we've got amount 5 and coins are 3 and 5. Okay, if we include coin 3, the amount will be 2 and coins are 3 and 5. Again, if I include coin 3, well, now the amount is -1, which says that don't go down. There is no solution on this branch. Here, if I exclude coin 3, amount is 2 and 5. Now, my coin is 5. If I include coin 5, again, I get a negative amount, which is an unhappy state for me because it says that there's no solution here. And if I exclude coin 5, the amount remains the same, but no more coins left. Turn it into red. Back to the top, still we have this branch to go on, which is excluding coin 3. The amount is 5 and coin 5. Now, if I include coin 5, the amount will be 0. We have reached the solution here. This is a base case which says that there's a solution on this path, which is if you exclude coin 2 and then exclude coin 3 and include coin 5, you'll get amount 5, which is obvious. This is the second way of making amount 5, just picking up a coin value of 5. So obviously the other branch won't get to a solution because there are no more coins left. So this is how our recursion 3 looks like. Let me do this. As we discussed before, there are two solutions for this problem when the amount is 5 and coins are 2, 3, and 5. And our base cases are, we have 3 base cases. 2 of them say that there's no solution, and 1 of them says that you have found a solution. When the amount is negative or there are no more coins left, it says that stop the recursion, there's no solution on this path. And when the amount is 0, it means that you have found a solution on the path you've been. Okay, now let's see how to implement CoinChanger recursive approach. I've implemented a piece of code which reads an integer from the console. Now I want to implement a method which counts all the combinations recursively. Let's name it CoinChange. Okay, what are the arguments? Well, it should be the amount and the coin that we are including or excluding in each step. How come? As you can see in recursion tree, in each step, amount or coin value changes. So each step has its own specific amount or coin value. So I include n and 0 as the coin index. And what I want in return is the total combinations. Okay, so I refactor this in coin index, and I prefer to refactor this to amount. Okay, now what's important in implementing a recursive method is that when to continue the recursion and when to stop. We're reaching to a base case is when we have to stop. So first thing I check is if the amount equals to 0, then return 1. It means that we have found the solution. There's a one solution on the path that we've been through. Otherwise, we have to continue the recursion. So we need to coin change. This is the coins array and the coin index that I've given to the method. The coin index is the same, but it's not over. This is the part that says include the coin. But what about the other part that says exclude the coin? But as you see, at the end, we have add up all the solutions we have got from both include option and exclude option. So we have to sum it up. We have to add these two branches together to get the final answer. We need to combine them together. That's why I add a plus here and say that coin change. I keep the amount untouched, and I say coin index plus 1. It means that I exclude the coin and go for the next one. Okay, but what about the base cases? And that says that there's no solution. So we need to add them here if amount is negative or our coin index is greater or equal to coins.length. Return 0. It means that there's no way, there's no answer on this path. So let's see how it works. Yeah, I run it. I give amount 5. The total combinations is 2, as we expected. You may ask that is the sort of the uh, coins array important or not? No, it's not important. It counts all the combinations, even if it looks sorted. If I mess it up, for example, 5, I will get the same answer. I enter amount 5. Still, total combination is 2. Okay, I hope you found my tutorial helpful. If you have any questions or need further assistance, feel free to reach out. Happy coding!